Hi, my name is Sev. I'm a Solutions Architect here at Amazon Web Services, and I'm glad you chose to join me here today for this session on using Amazon AI services to enhance your application with lifelike speech. As you can see from the icon on the right, the focus of the session will be around how Amazon Poly enabled you to make use of text-to-speech technology. We'll start by introducing the AWS machine learning stack and where Amazon Poly fits within. Then we will look at Amazon Poly and demonstrate some basic functionality. After that, I will show you how customers can use Open Standard Speech Synthesis Markup Language, or SSML, to further tune the speech samples. Finally, I will talk about a relatively recent feature, Brand Voice, that allows customers to develop exclusive use voices to give text-to-speech use cases a persona. So let's get started. We see the machine learning stack as having three key layers. The bottom layer is frameworks and infrastructure. This is aimed at developers who are either already deep experts on ML frameworks or are keen to crack open the textbooks to learn them. For these customers, we provide both the compute instances needed, for example GPU-enhanced PNG series, as well as the pre-built EC2 Amazon machine images loaded with popular frameworks such as Apache MX or TensorFlow. However, many customers don't want to deal with the undifferentiated heavy lifting of managing compute and infrastructure services, and so we offer the second layer. This layer, ML services, centers around Amazon Sagemaker. Sagemaker makes the process of developing, training, and deploying ML models easy and efficient by providing a fully managed environment. As of reInvent 2019, we also released Sagemaker Studio Ide, which developers can use throughout the development process. With it, developers can write code, track experiments, visualize data, and perform debugging and monitoring, all within a single integrated visual interface. Using Sagemaker still requires some ML know-how though, and therefore, we also offer the top layer, AI services. Here customers find a set of pre-trained models that satisfy a growing number of generic use cases. This democratizes access to AI and ML technologies because now all developers need to know is how to consume a RESTful API or use the AWS SDKs in order to add sophisticated functionality such as text extraction and even interactive chatbots to applications. And all of that without needing to train an ML model or knowing a framework. Our latest addition to the family are fraud detection, Code Guru, which helps with code reviews, and Contact Lens, which integrates with our contact center solution Amazon Connect. It will not be too surprising then that this top layer is also where we find Amazon Poly, which is the focus of today's session. Well, I've mentioned the name a few times now, so let's see what it actually is. Amazon Poly provides a growing number of voices, and now more recently lifelike ones, powered by neural networks that we will see shortly. To adapt to the occasion and intended audience, there's an option to have voices to act in neutral, newscaster, and conversational styles. Also, as we just saw, Amazon Poly is on the top layer of the ML stack and therefore offered via an API. These APIs are low latency so that it's possible to use dynamic generation in real-time systems and scenarios. On that note, where a use case permits, you can also pre-create and store speech samples and then reuse them as you like. Amazon Poly charges you only for generating and not for reusing the speech samples. Once created, they're yours. You are free to do with them as you like. Amazon Poly features voices suitable for use across geographies and cultures, and quite a few relevant to the ASEAN region too. As with all our services, the roadmap is largely customer-driven, so if you're finding a voice is missing, please reach out to your AWS representatives and they will log the request. But enough of my words. Like so many of our services, and in this case literally, we like to let them speak for themselves. Amazon Poly, please introduce yourself to the audience.
Welcome to the AWS Singapore Virtual Summit 2020.
And now in Mandarin.
欢迎参加2020年 AWS 新加坡虚拟峰会。
And German.
Willkommen beim AWS Singapore Virtual Summit 2020.
And finally.
Welcome to the AWS Singapore Virtual Summit 2020.
Thank you, Poly. Let's look at the two methods Amazon Poly uses to synthesize voice. This is also where I will explain what this lifelike deep learning is all about. Amazon Poly voices are one of two types. Traditionally, and for the standard voice, this is concatenative text-to-speech. Here we start with the sentence we want to synthesize. Then we map the text into its phonetic transcription. Those of you who have studied languages perhaps recognize this. Phonetic script conveys information on how to pronounce speech. In the final step, as the name concatenative TTS implies, we join the translations of the phonetic samples together to form a voice output. But we can do better. And so, Amazon Polly also features a neural text-to-speech system that can produce even higher quality voices than its standard voices. The NTTS system produces the most natural and human-like text-to-speech voices possible. Let's have a quick look at how this works. The Amazon Polyneural TTS system has two parts. A neural network that converts a sequence of phonemes, the most basic unit of language, into a sequence of spectrograms. These are snapshots of the energy levels in different frequency bands. The model chooses the spectrograms such that their frequency bands emphasize acoustic features that the human brain uses when processing speech. This then gets fed into the second part, which is a vocoder. This converts the spectrograms to speech waveforms, and when trained on a large datasets also used to build general-purpose concatenative synthesis systems, yields higher quality, more natural sounding voices. That's a lot of the theory. So now we just look at the difference in some examples. On the left, a sample text on ducks from Wikipedia. Let's hear the difference when using the two models. Here is standard.
Duck is the common name for numerous species in the waterfowl family Anatidae, which also includes swans and geese.
And here the neural counterpart.
Duck is the common name for numerous species in the waterfowl family Anatidae, which also includes swans and geese.
And on the right side, it's storybook time with Justin, a childlike voice, as he reads from this famous novel.
And now, sir, continued the doctor, since I now know there's such a fellow in my district, you may count I'll have an eye upon you day and night.
And once again, this time with the neural model.
And now, sir, continued the doctor, since I now know there's such a fellow in my district, you may count I'll have an eye upon you day and night.
Quite a noticeable difference, isn't it? It's not just the quality that is better with NTTS. We can also use it to change the style of the voice. Let's hear the message on the left, for example.
Breaking news. The AWS Summit isn't cancelled after all, and it's taking place virtually instead.
This message certainly deserves to be heard, and the newscaster style helps us to draw attention.
Breaking news. The AWS Summit isn't cancelled after all, and it's taking place virtually instead.
Here on the right is an instructional message example.
After all, learning to ride a bike as an adult is no harder than learning as a kid, as long as you take the same step-by-step approach to the process, and push grown-up fear and nerves out of the way.
Because we're trying to put people at ease, adopting a more conversational, casual style might help.
After all, learning to ride a bike as an adult is no harder than learning as a kid, as long as you take the same step-by-step approach to the process, and push grown-up fear and nerves out of the way.
Well, that's already quite cool. We can get even more fancy. Using Speech Synthesis Markup Language, SSML, we can instruct Amazon Polly to behave in specific ways. For example, I can use SSML to have Amazon Polly spell out the things it says.
My name is Sev. It's not really, but I say it is because SCVERIN space GASSAUER-FLEISSNER is no fun to spell out when booking a table at a restaurant.
When using SSML, the entire spoken text needs to be encapsulated within speak tags. We can use the AWS console as shown here, or provide the input file to the Polly API. When I created the samples for this session, I used Python SDK, and it took about 15 seconds to generate all of these. There are quite a few of these tags, and in the next few slides you will see some of them in action. In my first example, I used prosody tags to slow down speech when spelling out my name. Prosody refers to the patterns of stress and intonation in a language. I can also use these to speed my voice up. Let's assume we're building a live auction website and we wanted to use Amazon Polly to enhance the atmosphere. We could do something like this.
I'm at 500 and I want 550 bid on 550. I'm at 500. Would you go 550 for the gentleman in the corner? A paddling of 2,000 ducks is on offer. Do we get 600? A paddling of 2,000 ducks. We got 600 for the whole lot, sold for 600.
SSML can also help bring characters to life.
Alfred, did you know there is a city called Batman in Turkey?
Speech alone is great, but creating fully immersive experiences is more engaging. A challenge with combining audio and visual content is to keep them in sync. Enter Amazon Polly speech marks. Over the following slides, we will see how speech marks support synchronizing speech samples with visual displays by providing a second stream of metadata information when particular sentences, words, and sounds are pronounced. Let's assume we want to lip-sync story narration via a virtual storyteller. Below is a snippet of a scary story. This slide shows the AWS command line interface, CLI was used, but we could also do the same with the SDKs. I passed the sample text to Amazon Polly 2 times. The first time I asked for speech metadata, an excerpt of which can be seen here, and a second time for audio stream as usual. We can then use that information to create a lip-synced animation such as this.
The night was about to fall, and we were still lost in the forest. As she heard branches cracking, Mary started to whisper, "If you make any noise, they will find us. We need to walk silently to the lake."
If you're interested in how to create your own virtual host, I recommend you check out my colleague session on Amazon Sumerian. I'm sure that by now you can start to imagine all sorts of use cases or scenarios where you may want to use text-to-speech provided by Amazon Polly to enhance your products. However, for customers who want even more customization, it is now possible to get a brand new voice. This is an Amazon Polly voice that matches speaking styles, intonations, and tone of the persona customers wish to portray. This voice still supports all features available in the other neural text-to-speech voices, including the ones I just showed you. The produced voice is for the exclusive use of the customer who commissioned it. Brand Voice is created in collaboration with the part of the Amazon text-to-speech organization behind Alexa. So how does it work? This is a bespoke engagement where the customer defines the persona requirements. Then, voice actors are sourced in collaboration, customers and the Amazon Polly team. The voice actors are engaged, and Amazon Polly work with them through recording sessions to train the voice. Once finished, the team gives the customer access to their brand voice. Now the customer tests and accepts the voice, and then launches the brand voice in the use case. The process just mentioned was used by Kentucky Fried Chicken in Canada to bring to life their Colonel Sanders character. While the voice is exclusively for them, they kindly let us publish this sample on our public ML blog. And here it is.
Hi, I'm Colonel Sanders, the founder of Kentucky Fried Chicken. Let me tell you a joke. What do you call a chicken crossing the road? Poultry in motion. Got it? Poultry in motion. Food for laughter.
And speaking of customers, Amazon Polly has been adopted by many companies ranging from news agencies, smart learning, or financial services software providers to cover a range of use cases, including narration of podcasts, navigation instructions, or even learning a new language. Me and my colleagues would be thrilled to help you adopt Amazon Polly as part of your next application and look forward to you contacting us. But in the meantime, I've provided some useful links and material for you to get started. I especially like the second link, which shows you how to build a language translation service combining a number of AWS services, including Amazon Polly. The link also includes a CloudFormation stack, so you can spin up and have a play with it within minutes. And that's a wrap. Thank you so much for joining me today on this excursion into the habitat of the Amazon Polly.